Okay, we're going live. Isn't that fun? So today what I'm going to do is I'm going to start blundering through this machine learning program that is called PyTorch. And PyTorch uses a Jupyter notebook, and a Jupyter notebook is in Python, and it's teaching me matrix math, and it's using some really fun analogies. Like in order to learn how to multiply matrices, it's showing me that if we were to treat a 2 by 3 grid as a recipe with different food sources, like recipe 1 has 1 banana, 2 berries, and 0 milks, and recipe 2 has 2 bananas and 1 berry and 3 milks, and we multiplied that by a 3 by 2 matrix where you had the calories and protein characteristics of bananas, berries, and milk. The fact that you have in the first one, you've got 2 rows and 3 columns, and in the second one you have 3 rows and 2 columns, means you can multiply them, because in matrix math you can always handshake or multiply. Use this A symbol over here, A at B, which means multiply, but multiplying matrices, as long as the column information, which is the second part in a 2 by 3 matrix, because you always go row by column. So a 2 by 3, as long as the column information 3 matches the row information in the matrix you're trying to multiply by, which is here 3 rows by 2 columns, then you would multiply the first column entry on the first row with the first entry here in the column, and then the second entry with the second, and the third with the third. So that way you'd say, okay, so in the first recipe I have 1 banana worth 100 calories, so that's 100 calories. Then I have 2 berries worth 200 calories each, so that's 400, plus 100 is 500. And then I got 0 milks, 0 times 50 is 500. So recipe 1 gives you 500 calories. When we want to look at recipe 2, you do the same thing. You'd come onto this row here and you'd say, well, I'm multiplying recipe 2, the banana, 2 bananas at 100 calories is 200 calories. Then 1 berry times 200 calories is 200, so that makes 400. And then 3 milks times 50 calories is 150, so add that together, you get 550. Then you do the same thing for the protein. You would say, well, 1 banana is 5 proteins. 2 berries is 2 times 2, which is 4, which makes 9, and then 0 times 3, 0 milks times 3 proteins is 0, so it comes up to 9 proteins. And you do the same thing with recipe 2. You'd say, okay, 2 bananas times 5 proteins is 10, 1 berry times 2 is 2, so that makes 12, and 3 milks times 3 proteins makes 9, 12 times plus 9 is 21. So the matrix math makes a lot more sense when you look at it as these number blocks. And what you learn is that as long as the recipe columns, it doesn't matter how many recipes you have, as long as the ingredient columns are 3 and they're the same as the ingredient columns, the ingredient rows in your second matrix, you're really trying to figure out how these ingredients would multiply out if you were doing different recipes, which are in the rows here, and then the columns here are the calories and proteins. So you're really trying to multiply recipes by characteristics of those ingredients, as long as the ingredients match: bananas, berries, and milk. Bananas, berries, and milk. What a great way to understand matrix math in a practical sense. And then I have this Python code, which I'm running in PyTorch using a Jupyter lab. And then I'm using ChatGPT to help visualize it. Let's look at ChatGPT, because it's giving me some other code that I can do. I'm using matplotlib in here. I'll copy this code here, which is a number blocks world, and let's put it down here in a Jupyter cell. And it's teaching me this. Now here you got code that says recipe 1's matrix, recipe 2's matrix, and then the ingredient rows times the nutrients column. So it gives me some commenting to know what we're looking at, and then it runs the tensors, and it says, yeah, the number of berries, bananas, and milk, and it does the matrix math. It's C is equal to A, handshake, B, recipes times nutrients. A great way to think about it, and then it gives you the names of each and prints out those. So let's see when we run this, what the Jupyter Notebook gives us. Well, there it gives us the tensor, and that just shows us that these two multiplying are giving us these results. But the next part of the code is the fun part, because after we've gotten that, then we have the MATLib. It's going to start to draw it in friendly colors. And so now, I guess this is using NumPy, which is a matplotlib, right? Matplot library, and an IPython display. So we've installed those dependencies. And now when we run this, if everything works, let's see what happens. It's taking its sweet time. Still taking its sweet time. In fact, it ain't done nothing yet. Not sure why. Let's see what the code is telling us here. Oh, then you have to animate. So I guess that maybe that's just storing some information. So I'll put in the next piece of code about the animated handshake. See if that does anything. Otherwise, I'm going to be totally mystified, and that's going to be embarrassing. How to use the imagined animation? Well, let's see. Maybe I have to do something more than just copy and paste. Maybe I was too glib. Oh, there we go. No, we have it. We have it here. So there's the result, and it did the calculations. Just one cell filled, the total for the smoothie and the nutrient, and it's showing us that matrix, and then it's showing us the other matrix, and it spits a result out here with happy faces. 0 for these and 500 for this smoothie. So it's the handshake for recipe 1 and protein with an animation. And I guess, I don't know, if I run it again, it looks like it was actually animating and calculating. But I think to run it again, I think you have to go in here and hit escape, is it? You come in here and hit escape and then try to run it again. Yeah. So now it's doing the calculation. It's a running total. It starts doing the math and bang, then it shows up. So this is a fun piece of code, and this is how I'm learning this stuff because I've never done coding. So I'm learning Python by working with my AI ally and working to learn PyTorch so that I can learn to make AI. So this is my first step to learn a little bit of matrix math. And it says what it does. It'll highlight the matching cell from A's row and from B's column, show speech bubbles, 2 scoops of banana, talking to 100 calories scoop, adding them up with the running total, and then printing it out. And you can say to Nye, look, buddy, the smoothie recipe row is talking to the nutrient column. Each ingredient number block says how many scoops we used, and the nutrient number block says how much energy it has per scoop. They shake hands, multiply, and we add the handshakes to get the final number for the smoothie's energy. Now it says if we can tweak the colors and add emojis. I love the suggestions that this gives me, so I'm going to say go for it. And I'm going to rerun this again because I've learned this technique of clicking here, hitting escape, and then rerunning, and watching this running total, and bingo, getting there. So what we're doing is we're saying, well, we got one, we'd have to look up the other thing way up here, one banana. So it's, what was it? It was banana, berry, and milk. So the recipe is banana, berry, milk. So 1 banana at 100 calories and 2 berries at 200 makes 400, plus 100 is 500, and then 0 milks at 50. It's still just 500. And that's the result that you see in that row. And that's giving you just one cell filled, the total. And I suppose what we'd have to do is modify the code to get the other matches. And that's something I'm going to have to learn some actual Python to do so that I could change that, because it's doing rows A, columns B. Should should be some comments from here. Lay out the parameters. We're using row I and column J, product row time column for K in range. So if I wanted to do the other columns, example 1 is this. So if I want to animate the other one, then I would have to change this code, and I guess I could comment this out. So let me copy this, see if I understand this. This is what Stephen Reeder was telling my wife about this. You look at the examples and then you try to figure out for yourself what to do. So if I have, oh, he already gave it to me. Look at that. So all I needed to do is comment this one out and then uncomment handshake B, which is going to run AB, and it's going to do J, or the column number 1, because this is column 0. That was being used in the first one. It was column 0 and row 0, column 0. So here we're doing row 0, which is the first one, column J, which is this column 1, which is the second, because it starts with 0, 0, 1, 2. So don't get fooled by that. And so when I run this now, once again, I'll hit escape, and then I will run it. Let's see it run, and it should do the second cell. There we go, 9. So that's equivalent to what we had way up here. Remember? So this is what we're actually recreating, but we're doing it with an animation by uncommenting stuff. So now if we comment that one back, so that would be commented out, and then we do recipe 2, which is row 1 with column 0. So row 1 with this column here, which is the milk, being set to 0, and we run that, then we get, so it gives you this error unless you hit escape. Oh, and it's unexpected indent. Let's see, maybe it's still a problem. So what did I do? Command Z, go back, go back, go back. There we go. Take this out, but don't indent. Nope, still giving me an unexpected indent. Why is that? Maybe I need to pull it back, maybe? So no indent at all. There we go. And now it's running, and it's going to give us this column right here. 350, 550. Exactly what we saw there. So this is a really fun way to work with Python, and it's setting me up to get into machine learning. So yay for that. And I think what I'll do is I'll just save this notebook as, I will save this as matrix lessons. And no, I can't, there's no pausing room. It's the same. Save the changes. Discard that. Ooh, that's a mess in it. All right, well, I don't know what happened there, but I still have that code, so I can use it. But now I want to move on, and what I want to do, having done that, oh, we had a network problem. That's the thing, we lost the network. All right. So I was asking it to go for this, and I was going to put in some friendlies in there. Let's see if it does come up with that. It's thinking. And while it's thinking, the way that I have this opening up is ChatGPT helped me create a batch file so that if I were to close my Jupyter notebook, leave it completely. Stop thinking. Why did you stop thinking? Oh, it's doing it. All right. So it's going to work on that. But what we did, what ChatGPT gave me was a way to go into my downloads folder, and I created a batch file that literally launches the environment. So it opens up, it opens the command prompt, it puts in the commands that are needed, and it launches a browser, which happens to be Microsoft Edge browser, and brings me right into Jupyter. So I don't have to think through that anymore. I had to learn it when I started, but now I have a batch file. If I wanted to look at the batch file just to make sure that I don't lose that, then I can open this in, oh, it's launching it. So edit in Notepad. So there it is. It says echo off, and then a remark, launch Jupyter Lab inside the PyTorch environment. It says change to the D drive, which is where I have the Python installed, then change directory to the D drive to Python-environments, call PyTorch environment script and activate that, and then it says starting Jupyter Lab in the Torch environment, and then launches the Jupyter Lab. So that's what that batch file does. That makes it a whole lot easier to get in each time I want to do a session. All right, so I'm in here to do a session, and I go here, and now we have helpers. This says, let's give number blocks, spaces, and speech bubbles. Below are 2 Jupyter cells you can paste and run. It's going to walk me through it slowly. 2 tiny functions to draw number block squares with eyes and smiles and a speech bubble. So it's importing Numpy. Numpy is NP, the matplot libraries, patches, and then it's assigning colors that feel like number blocks, and then it's drawing them and coloring them, and let's try that out. Since this is my first day, I assume that over time I'm going to get more and more familiar with the actual code. You can change the colors, obviously. You can change the patches. This is what Inas is working on in her thing too, looking at the code and learning where to change parameters. So we'll run this, and I guess that's gone into memory because it isn't doing anything yet. Now call cell 2. This is drawing your 2 input plates, recipes, and ingredients, and then puts bubbles that show the multiply and add steps to change which row column to the demo at the bottom. So let's paste that in, finding the 2 plates. So let's get that information in there. Run it. Oh, and then yes, bang, you got it. So there you have this row and this row. There is a problem. Something's missing from fonts. The fonts are missing, but I don't care so much about that. It is working. It's nice. It's got some faces and eyes, more friendly for kids. Got the same results. Okay, and then having gone through that, how to change the demo target, show recipe 2 with protein, row I equals 1 and column J equals 1 in cell 2, and run it again. And so what we would do is, let's see where we would do that. Set row I equals 1. So row I equals 1, where do we have that? So show the rows, privilege label, go up. Let me see. I should be able to do a control F, right? Let's say row I, show the row talking which, okay, so row I equals 0 here. So let's set row I equals 1. And I think you have to hit escape to do that. Where did it go? Somewhere in there. Looks like I lost it again. I should have been paying attention, shouldn't I? So let's go up 1, let's go down 1. Let's try it again. Row I. Why it's giving me that yellow environment thing. So if I escape, nothing happens. Well, subplots, axes, row, tight layout. There it is. I equals 1. Now, what was it telling us we should be able to do? We should be able to change row I equals 1 and column J equals 1 in cell 2. This is cell 2. And then rerun it. So 0 is equals the recipe, 1, 1, recipe 2. Let's see if that changes anything. Yeah. So it's giving us that information there, and it's actually showing us what we're multiplying. 2 by 5, 1 by 2, 3 by 3 equals 21. That's pretty neat. So if I set this row I equals 2, oh, didn't mean to do that. Row I equals 2 and row J equals 1. Let's see what that gives. It says there's an error. Row I equals 2, row J equals 1. I don't know. Let's see what's the error message. IK item. Index 2 is out of bounds because it's only a size 2. So I wasn't even paying attention to my matrix. Let's look at it again. So row I is out of bounds. So let's say, oh, because it's only got 2 rows and they're called 0 and 1. So, duh. So let's do this one. Row I equals 0, which would be banana. And then we will make it into J. We'll go for milk. So we'll do 0, 1, 2. Milk for 2. That's what we'll do. So, where to go? There it is. As long as you keep it in bounds, then we run it. That should have given us, nope, it still says it's out of bounds. Trace back. It's out of bounds for dimension 1 with size 2. Maybe because I didn't hit escape on it. Let's try that. And then let's try to run it. Let's see if this works. Nope, still doesn't like it. So I'm not thinking this through properly, but I'm kind of tired, so I'm going to just run this at 1 and rerun it. And it did work there, and it shows that we have 2 times 2 and 0 times 3, and we come up with 9 over there. So as long as I'm staying within the matrix, I should be getting this right. If I do 0 and 0 and run that, then we're looking at 500. We're looking over here. So it's 0, which is this row. It's showing it. It's nice. It's identifying it. And it's saying this column. So it's 0 and 0. Oh, right, because this is 0, 1, and this is 0, 1, 2, 0, 1, 2, 0, 1. So I wasn't even thinking this through. Yeah, so obviously then 0, 0 would be this row and this column. Now, if I want to do this row and this column, it would be 0, 1. So I'll go back up here and I'll make column J 1 and I'll run it again. And now it's this row and this column. And that leads to 9 over there. And if I do recipe 2, which is this row 1, and I do it with column 0, which is the first column there, then I'm doing this row down here, as you can see it says there, and then this column, and it's giving me 550 for that. And then finally we would go and do this and this. So we go row I, which is this row 1, the I, and then the J, we're going to use this column. And by doing that, we should see something over here. So let's run that. Yeah, and then we get back down to the 21. So that's pretty fun to be able to do this. And then it says, today to 9, see the left plate? That's how many scoops of banana, berry, and milk each smoothie uses. The middle plate shows how much energy. It's over there. How much energy? Put it over there. How much energy is calories and muscle food, protein each scoop has. The bubbles show a handshake. There's the handshake there for each of those, so it lines it up. And then the right plate shows the totals for the smoothie right there. It's Lego math. Multiply, then add the handshake. Oh, and it says we can add sound effects. So this is great. You can just keep going through this and say, sound effects, whoopee. And anybody who says that working with AI is leading to brain rot doesn't really understand those of us who've suffered so much through school with deadlines and disapproval and judgment, and then said, well, I'm not good at math, or I'm not good at computer programming, so I'm never going to do it. With this very friendly tutor here, I'm motivated to learn matrix math. I'm motivated to learn Python coding because I'm playing. So we're going to go full on number blocks meets Pixar Lego Smoothie Showdown. Here's a version with sound effects. All right, run this once. That sets up our friendly world. So let's go back to our Pi notebook. And let's go to this cell here. And let's run that. All right. And it has a speech bubble. And then once we've set that up, we're going to go step 2, run this to make the scene come alive. It's got a little clapboard from Hollywood. And then when we run the second part of the code, then we get, boom. Again, it's giving error messages that we don't have certain fonts. Deja vu sans, so we can't have that. But anyway, it ran the first thing from Playdate, and it says, whoopee, the number blocks multiplied and added their powers. I didn't hear any sound. I'm not sure why, because it said that we would have it. Maybe it doesn't have them. It's all glyphs. I don't know. It did print whoopee, but it's not making a sound. I guess it's saying a sound. I don't see anywhere in the code where it actually makes a sound. It just says whoopee, and as if it plays a musical tone, but it's not really doing that. I can run it again and try to listen carefully. No. But it's putting in these whoopies and these things here, and it's saying smoothie calories. It's telling us which one has what. So that implies that if we go back and change this again, change the row I to 1 and rerun this, then it's going to give us this one down here, and it says smoothie calories 550. And if we change this to 1 here and 0 here, and ran it, then it's giving us this one here. So we're getting the smoothie totals. And then finally we can do the other one, but it's sort of trivial at this point. I understand now what we're doing. So make this 1 and 1 from the I and J, and rerun it. And boom, it's now showing me this protein for the recipe 2, how much protein there is. So that's pretty fun. I'm going to ask chat about that, though. Would you like to make the next version animated with sound words popping in sequence? And we're supposed to say, okay, now which is the number blocks? Boop, zap, pop. Each colored number block on the left shows how many scoops of each fruit go into our smoothie, and they send little energy beams across to the middle chart where the food power lives. Each handshake does bzz as they multiply, and all those zaps add up. I'm going to say yes. Why not? Let's animate, but tell me, was I supposed, or were we supposed to hear a sound or just see the icons and words? I don't see a call for audio. And I'm pretty sure what the answer is. It's probably going to be that, yeah, it was just simulating that. But we know it's all possible. Providing animation with sound, stop for 9 seconds. Grr. Great question. You didn't miss anything. The cells you made showed visual sound words and emojis, not the real. If you like actual sound, you have 2 easy options. Visual animation, simple beeps on Windows. I'll give you both. Copy it into Jupyter and run in order. No internet needed. All right. Well, it's going to give us both. I don't know if it's done yet or not. Seems like it's still processing. Because it ain't letting me copy yet. Oh, there we go. It's still writing. So what is this doing? This is using Matplot library, a fancy arrow patch, rectangle, circle, and arcs. It's drawing number blocks. It's got the colors. Still thinking, so we're not quite there yet. And what I hope to get to tonight is actually starting some machine learning. That's the most exciting. Okay, so this has no audio. This is just to redo our helpers. So we're going to come in here, come into a different cell, paste that in. And now we're going to play it. That sets it up. We're going to go back and now get our animation cell. Copy. And it's supposed to see arrows and bubbles appear one by one. No real audio. So let's try that. And run it. And I guess that's what it calls an animation. It goes through one by one through each of the things, the different results, and then goes whoopee. But I didn't really see that as an animation, maybe because I wasn't looking as it was building. So don't know why that thinks that's an animation. I'll try to run it again, but it happens so quickly. So I guess by animation they just mean it's running through several scenarios, but it's not flipping them on the screen, I guess. Okay, well that's fair enough. I don't mind that. Let's see what it says about the sounds. So this is with real beeps. It's just a normal. They didn't appear, they just went on really fast. Okay, so this one here, it's not studio quality, but it's fun and immediate. And that's one big piece of play. And put that Python code in and run it. There you go. Okay, good fun. 1, 2, 3, 4. Beep it. 1, 2, 3, 4 as it was loading, but it loaded it so super fast that we didn't see anything. But that's cool. If we heard the beeps, then before you saw sound word only, now real sound needs code. I gave you Windows beeper version. Then we could do Mario style using NumPy. Sine tone sound effects. Oh yeah. Go. And we might as well just have that dialogue and see what the capabilities are. Okay. Heck yeah, let's add real sound. Okay, now here comes the sound. The number box showing. I'm just going to mute the audio for a second. Audio input capture. All right, so we've got a result here, and helpers run once. This is going to go into a cell, and then we're going to run it. And let's see what we get. Nothing. I guess it's just a helper. It's got chord or something, silence, duration. It's got wave, triangle, and square waves and sine waves at a frequency of 660 and a duration of a quarter second and a volume of 0.2 using a sine wave. So it's got else as ifs and all that, concatenating them. So it's just creating sound using sine waves rather than Windows beeps. And then after that code, you animate and play a tiny soundtrack. It should be visual arrows appearing one by one. Generate a 3-beat sequence, one per handshake, then a final whoopee chord. If you browse the box autoplay, then click the play button that appears. Let's see if we can get anything here. So we go like this, and we play. Cute. And then there's a play thing here. 1, 2, 3, 4. So that's cute. So this is sort of like now realizing that you can use Python code and a program like Jupyter Lab and PyTorch to create graphics and to create sounds. We're beginning to see then the power that tensors allow for, because tensors are either zero-dimensional, which would be a scalar, like a number like 6 or 7. Then they can be vectors, which are one-dimensional. which would be like a row of information. They could be matrices, which are two-dimensional, which is a column in a row, which is what we see here. That's a matrix. And then it can be three-dimensional, which would be like a cube, like a block, like the number blocks stack up, or an image which has RGB and has a various dimension, like 64 pixels by 64 pixels. And so then you get you get the ability to encode images and video and animation. And that's what tensor flows are about. And that's when you begin to process this, you can start then training the data. So this is my first day starting to play with this and starting to understand tensors and PyTorch. One moment, for a second, I'm going to let something process. Okay, so what we're going to do now is call response. Each ingredient says its name. Gosh, I mean, this just gets more and more fun. It's like playing a game. Like, heck yeah. And iteratively, it's tutoring me how to get to this point. And in the Jupyter Notebook, when I save the notebook, I have this save notebook as scripts. I'm going to call this matrix tutorial. But it always ends up, oh, it did fine. So I have this saved. So I can keep this code and I can explore it at my leisure. I encourage you all to do this too. Yep. So let's see what it came up with now. Oh, let's make it a column response show. 2 cells, paste them in order in your Jupyter Notebook, then build on what you already have. This gives each ingredient its own emoji and sound. And you can switch to protein by setting column J equals 1. Yeah, because protein is, in fact, this column here, protein. It's column J. It's column I. I'm sorry, this is 0 in J, and this is 1 in J. And in this other one over here, this is 0 in I, and this is 1 in I. So we'll go to this piece of code, and we will put that in the cell. And we'll run it. That should set it up. And then we column response animation and ingredient voices. It'll announce itself with emoji and sound, and multiply and add phase of matching beep. Final chord will be whoopee. And then we'll change it if we want calories or protein, so we can get different targets. So copy that code, and we will run it. So what it's saying is, I'm banana, 1 scoop, I'm berry, 2 scoops, 100 per scoop, then yields 100 calories. 200 per scoop equals 400, and that's why we result 500 over here. Here it's saying, I'm banana, 1 scoop, I'm berry, 2 scoops, and I'm milk, 0 scoop. And when we're looking at this, 200 per scoop, 450 equals 50 per scoop, 0 calories. Oh yeah, 100 per scoop is 100 plus 200 per scoop is 400 plus 50 per scoop equals 0, gives you the 550 as the result. What great fun then to be able to have it identify which columns and which rows it's doing for the matrix math, and to have it play little sounds. Very cute. Let's see what other suggestions it has. It says protein, oh yeah, set it to column J equals 1 and run it again, or set O and then add an ingredient. You can expand A and B an ingredient and flow consistently. And it wants to know if we want to bundle it. I'm not going to do that right now. What I want to work on now is, This is great. Thanks. I'm always trying to be polite to ChatGPT. I'll do that with you later. For now, can we get started on training an AI model? Where do we go from here for a beginner like me? Let's see what it says, because that's the goal, is to start doing machine learning. And we're in Jupyter. We have the setup. We've got PyTorch. So if we want to train a model, we should start getting at it. So heck yes, we're ready. Let's start with 2 beginner-friendly training exercises you can run in your Jupyter Notebook today. A tiny toy model, no download, just runs in seconds. The flow makes sense, and then a real image classifier on fashion MNIST, downloads 30 megabytes, still simple. Now hold my hand, thank you. So tiny training. This will teach you the basic rhythm. Get data, build model, choose loss and optimizer, train, loop, and evaluate. Will fit a line, y equals 3x plus noise. Your GPU will be used if available. So set it up with, I'll have to wait for this to finish calculating. So using AI to make AI. Let's see how this works. I think I'm going to start a new Python 3. I have a new cell for it. I'm going to save it so I know this is save notebook as my first machine learning. Save that. Let's go with that. All right, there's my first machine learning. Let's see what we got in this. Part 1, copy the code that imports Torch. So it starts the math, it goes random, and uses CUDA, CPU, and we run that. Okay, next part. Go to, you should see CUDA good, and CPU fine, good. Still fine, but CUDA is the NVIDIA chip, I think. So now make a tiny synthetic data set. So this data set is about y equals 3x plus 1 plus noise at an n of 512. That's the sample size. And then it'll create a line space, and then it'll do the math, and it'll do a shape. So let's see what that does. It created a matrix. All right, so 1 by 2, and so 1 by 2, and now we're going to go here and take the tiny model we're going to define, and tiny 2-layer machine learning program just to see a neural net. It models it and optimizes. Let's see what that does. Okay. Oh no, maybe it's still running. And now let's go to train the loop. So let's train a loop. Hoping I'm getting this right. I love to blunder into things without knowing what the heck I'm doing, and then just dialogue to learn it. Okay, so epic 20, 40, 60, 80, 100 with some losses, whatever that means. And then you'll see the loss go down. That's called learning. Okay, yeah, the loss is going down from 0.1 to 0.1069 to 101 to 0.09, 0.09. So as it runs, it is losing less. So that's training, it says. Okay. Then a quick check. What the model predicts and what the true function is. So you put that in, and we're going to test it and see if the predicted equals what the machine did. So X is this matrix here, and the predicted Y is this. What is that? How do I interpret that? You just trained your first PyTorch model. Right? I don't know what the heck it means, but it doesn't look very close. Like that's X and that's Y. So yeah, no. Of course, the math is there. So there's a formula, and the formula is a point slope formula, which we had up here to defined as y equals 3 times x plus 1. So it's 3 times x plus 1. When you model 3 times 0, and you add 1, you get about 1, which is 0.945 with the variation. Here, if you had 3 times negative 1.5, you get negative negative 4.5 plus 1. You'd have to subtract 1 because it's plus in a minus environment, so it's 3.58. Here, if you multiplied, you get 4.5 plus 1 would be 5.5, and there's a little variance. So it did work. It did what it's supposed to, and it says we've trained our first model. I don't know. I guess it worked. I still have to investigate what it all means, but yay, we're training a model. Part 2, real images, t-shirts, shoots, and bags. We trained a tiny CNN is a neural network, computer neural network that recognizes clothing items. Aha, simple but real. That gets exciting. Okay, good. Okay. No, I can't stop. Okay, so I think we have the model ready to run. So we go on real images and we copy this code, which installs, we've already installed PyTorch and now Matplot library. Let's just make sure Torch Vision is there. It should be. If not, we should see this. So let's go to here and import it. It'll probably tell us if we already have it. Yeah, it's there. All right, so now we go to, there's no error, so we don't have to install it. The data auto downloads 30 megabytes for the first time, so we're going to import Torch Vision transforms as T, and then import data sets in the data loader. It's going to normalize to roughly 0 mean for faster training, and then it's going to get this fashion data. So let's run that. And there it goes. It's pulling that data in. And while it's pulling it in, we see tiny computer neural network copy this code. What is that going to do? It's going to pull in stuff it defines. So I'm not sure what this code does. As a total beginner, how would I know? But I'm looking forward to seeing the output, and then I can have ChatGPT explain to me what each thing does if it seems relevant to my task. It's almost done downloading. Almost there. And 100%. Good. So now we will take this code. So it's running more than once, and maybe it needs to run several times. So it's going faster each time. Okay, so that's the output. Output is the length of the training something and the test. And they're both 6,000 and 1,000. Anyway, now we can import and run the model. And finally, train for a few epochs. This may be as underwhelming as the stuff that Nas is doing in class, where you run the Python and all you see are a bunch of numbers spit out, even though it's supposed to do great things in ArcGIS. I don't know what to expect. Most of these things are probably just confirmations that things are working. you should see test accuracy climb above 0.85, 0.90 in just a few epochs. So epoch 1 is at 0.5, 0.8, 0.858 for the accuracy, so there's the losses. The accuracy should climb above 0.858, now it's running it again. So this is a lot like what Anas was going through with her own training. You're seeing test results of speeds and accuracy, but no, but it is climbing. All right, so it's climbing again. All right, so it's obviously running the model and testing the accuracy. Now we'll copy the code, which is peek at predictions. And see what that does. This is a kid-friendly quick map of what's happening. Tensor is a neat box of numbers. Images are stacks of pixel numbers. Data loader is a helper that hands you the mini boxes to training is fast. Model is a machine made of layers. Oh, it did actually give us graphics. Good. That returns input numbers into output guesses. Loss is how wrong were we? Number we try to shrink. Optimizer is the crank that nudges it to be less wrong. Epoch is one lap through the training data. Accuracy is how often did we guess right. If something goes wrong, then you close Jupyter. You have to run. If you're not in the right computer, was computer available false. Out of memory, downloads blocked. Where we go next, you pick. Add data augmentation. So I guess what we're doing is training a model on these graphics that it downloaded, predicting an ankle boot, saying, yeah, that's an ankle boot. Predicting a pullover, saying, yeah, that's a pullover. Predicting trousers, saying, yeah, those are trousers. Predicting trousers, saying, yeah, those are trousers. Shirt, trouser, coat, and shirt. That means if at some point we were able to put in other figures, then it should be able to tell us if we've loaded up a shoe or a trouser or a pullover, and that's what we're going to have to learn to do, because I don't know the data set at all. So we're not there yet, but we're getting to the point where we're learning how to do this predictive model. So where do you get to go next? Add data augmentation, random flips crops to improve accuracy, color images with a slightly bigger CNN, move to VS Code script, build a project folder, start a tiny image data of your own, classify fuel loss, object you photograph. That's the one that sounds fun, my own photos. And that's all I'm going to do, because that's going to take a little more time. And so I'll come back to this and show what the next steps were. But if this encourages you at all to stop being a mere consumer of AI and being a prosumer of AI, then what I'm hoping to do with my classes is get to the point where we bypass the sustainability conundrum for AI, because we consider the models that are being developed to be infrastructure investment. And once they're developed, they should be able to run on distributed networks, on local servers, sort of like we do with the protein folding, distributed computing, with edge computing, with the SETI or Search for Extraterrestrial Intelligence, where we're not using massive data servers, processing power so we can find out recipes for making chocolate chip cookies. We're working as distributed communities with decentralized energy, solar, wind, micro hydropower, geothermal power, biodigester power, and running our local computers networked to lend each other processing power, running the models which have already been created. Because the most energy and water intensive stage is creating the large language models. Running them doesn't use as much energy, but we have this whole centralized command and control economy that's causing problems. And I think that we should, as the body politic, as the public, invest in infrastructure for artificial intelligence, but then we should make the code freely available for everybody everywhere to then run locally. and that would really take care of it in many regards. We would need to build more coal power plants or nuclear power plants or fossil fuel power plants, and we wouldn't need to use water that isn't being recycled on site, and we could use the waste heat. Where most of the energy and water comes from cooling these things off, but if you had district heating and you had the smaller community data centers helping to carry that heat off, to heat public baths, to heat processing heat, um, to heat buildings in the winter, then we're doing industrial ecology and we're much better off. So let me stop here because I'm gonna want to go through this code and start experimenting, but I'm really excited by the idea of using PyTorch, and I hope you are too, and catch up with you later.